Hi everyone. So in this video, we're going to go ahead and be talking about atomic number and mass number. And these two quantities are really important to chemists because they help us determine the number of protons, neutrons, and electrons in an atom. Now, if you haven't yet watched the video on the structure of the atom, please go ahead, pause this, and go watch that video first because it's going to make your life a lot easier when I go ahead and use those terms. So as a chemist, one of my most used tools is actually the periodic table. So on the periodic table, each element has its own element symbol box, and they all have a general structure something like this. So in the middle of that box is going to be the element symbol, designated by a generic letter X in this case. And this describes the identity of the element. Now, usually element symbols have 1 to 2 letters involved with them. Some old periodic tables will actually have 3 letters because that was a temporary naming system used until elements got their official name when we were filling out that last row of the periodic table. But in general, they should just have 1 to 2 letters. Now, there's actually 2 different sets of numbers that you'll see in each element symbol box. The first one is the smaller of the 2 options and is the atomic number. Usually that's in the upper left-hand corner, but sometimes it moves around. So the atomic number describes the number of protons that an element has. And each element has a different atomic number. This is what makes them unique. So this is just like every person in the United States has a different social security number. Each element has its own unique atomic number. So hydrogen always has an atomic number of 1. Helium always has an atomic number of 2. The other number in the element symbol box is the mass number, and this is always the larger of the 2 numbers in that element symbol box. Now, sometimes we actually have the atomic weight listed instead of the mass number. If that happens, we're going to have a decimal involved, so something like 12.01. If that's the case, we need to round to the nearest whole number to actually get the mass number. So we need to do a little bit of math here. If it's 0.5 or up, we round up to the next biggest number. If it's less than 0.5 for the decimal, we're going to round down. The reason why we actually need to round is because the mass number describes the number of protons and neutrons in an atom. So we can't have fractions or partial parts of a proton or a neutron. We can only have whole numbers. So therefore, the mass number must also be a whole number. So just to give you an example for the element fluorine, its element symbol is F, which is that letter in the middle. It has an atomic number of 9. Remember, that's always the smaller of the 2 numbers in the element symbol box. And then at the bottom, we're going to go ahead and take that atomic weight value of 19.0 and round it to 19 to get the mass value. So as I said before, the reason why we care about the atomic number and the mass number is because they can be used to find the number of subatomic particles in an atom. So for protons, our life is really easy. The number of protons always equals the atomic number. So we can just write that down, no math involved. For neutrons, it gets a little bit more complicated. We need to take the rounded mass number and subtract the atomic number from that to find the number of neutrons. And then for electrons, we take the atomic number minus the charge. And we're going to spend a whole lot more time talking about charge when we get to ions. But for right now, a general rule of thumb is if I don't tell you otherwise, you can assume that your atom is neutral, meaning the number of protons is equal to the number of electrons, which would also be equal to the atomic number. Again, that's only if it's neutral. Unless I tell you otherwise for right now, assume that the atom is. So protons equals electrons equals the atomic number. Okay, so let's go ahead and actually do an example problem. So we're going to calculate the number of subatomic particles in fluorine by filling out this table. So first, our symbol is going to be that letter in the middle, so that is F. The atomic number is the smaller of the 2 numbers, so that is 9. And then the mass number is going to be the rounded number that is the larger of the 2 options. So 19.0 rounds just plain old 19. The charge I'm not told about, so I'm going to assume that it is 0. To calculate the number of protons, I want to look back at the atomic number. So therefore, the number of protons is equal to 9. To find the number of neutrons, I take the mass number minus the atomic number. So 19 minus 9, which gives me 10 neutrons. And then to find the number of electrons, because my charge is 0, I take my atomic number minus my charge, so 9 minus 0, I have 9 protons. So one thing I want to point out here, these numbers do not need to be the same. Sometimes protons equals electrons, but that isn't always true, especially if you have a charge. Sometimes the number of protons equals the number of neutrons, but that isn't always true. As we see here, the numbers are different. Okay, so this is an example I want you to try on your own with the element boron. So I've already given you the element symbol box. Just go ahead, pause the video, fill out the rest of the boxes, and then we'll talk about it in a few seconds. Okay, the symbol for boron is the letter B. The atomic number is going to be 5. Remember, that is the smaller of the two numbers present. And then the mass number is going to be the larger of the two numbers. So in this case, 10.81. But don't forget to round it. So 10.81, we're going to round that up to 11. Okay, remember, we can't have a decimal for the mass number because we can't have part of a proton or a neutron. The charge we're not told, so we're going to assume that it is 0. And now we can get down to the protons, neutrons, and electrons. So the atomic number always tells us the number of protons, so we're going to have 5 protons. To get the number of neutrons, we're going to take the mass number, which is 11, and subtract the atomic number, which is 5. So 11 minus 5 gives us 6 neutrons. And then to find the number of electrons, because our atom is neutral, it has no charge, the atomic number is going to be equal to the number of electrons for this case. So we have 5 electrons as well. So just to recap really quickly, we talked about the parts of an element symbol box, and then we talked about how to determine the number of protons, neutrons, and electrons from the atomic number and the mass number. So protons is equal to the atomic number. Neutrons, we need to subtract those two values. And the electrons is going to depend upon whether or not you have a charge. So if you have any questions, please let me know. Otherwise, have a great day, everyone. Bye.